Problem 6, section 4.3. Evaluate the definite integral. So notice this is no longer 0 to x or 2 to x. Both ends limits are numbers. So such an integral is called definite integral. Let's remind ourselves what the fundamental theorem of calculus says about definite integrals. So first of all, the first part of fundamental theorem of calculus says if the lower limit is a number, upper limit is a variable, then when you take the derivative, you get the function back. Okay? The second part says this: if the limits are both pure numbers, then you just have to find any antiderivative of the function inside, evaluate it at the upper limit, minus evaluate it at the lower limit. That's your answer. So if both of these are pure numbers, you have to find antiderivative of the function inside, evaluate upstairs, evaluate it downstairs, and find the difference. Okay, so this is what we are going to use for, this is problem 5. Okay, so let's go. Problem 5 is integral negative 2 to 5 of 7 dx. Negative 2 to 5. So notice they are both numbers, so part 2 applies. So what do we need? Our function is 7, constant function. By the second part of the fundamental theorem of calculus, we need to find an antiderivative of this constant function. An antiderivative is 7x. You see, antiderivative, how do we find antiderivative? 7 has no x, that is power of x is 0. So you have to increase the power by 1 and divide by the new power. So it's simply 0 plus 1 is 1. That's the power divided by 1. So for any constant, mind you, the antiderivative is constant times x or whatever is the running variable. Part 2 of fundamental theorem of calculus says integral a to b fx dx is capital F at the upper limit minus capital F at the lower limit, these being antiderivative. So integral negative 2 to 5 of 7 is, we'll find its antiderivative 7x, evaluate it at 5 minus 7x, evaluate at negative 2. So 7 times 5 minus 7 times negative 2. So that became a 14, this became a 35. Together that's a 49. Correct. Go to the next problem. Here, integral 2 to 6 4x plus 3 dx. Again, these are purely numbers, so this is called definite integral. So find antiderivative of this, evaluate at 6 minus antiderivative of this, evaluate at 2. So we are using the same approach. That's your function. Its antiderivative. Increase the power of x by 1 and divide by the same power. Okay, the new power. Plus 3. 3 is a constant. You have plus 3x. Notice when you actually take antiderivative, you usually add a c. But why would I add c? I'm allowed to take any antiderivative. So I just let c be 0. That's why you don't see c anymore. All right, constant anymore, because you can choose any antiderivative. All right, simplifying, 2 goes in 4 twice, x squared plus 3x. So that's the expression. I want to evaluate at 6 minus that same expression evaluated at 2. So that's what it is. 2, 6 squared plus 3 times 6 minus 2, 2 squared plus 3 times 2. Don't forget these extra parentheses. That way the minus applies to everybody after. So this is 6 squared is 36, 2 times 36, 72. 3 times 6, 18. 72 plus 18, 90. 2 squared is 4. 2 times 4 is 8. 3 times 2 is 6. 8 plus 4, 16. 90 minus 14, 76. All right, let's go one more problem. Okay, again, definite integral from 1 to 8, 10 over radical x. All right. So you want to find antiderivative of this. 10 over radical x. Rewrite it. Radical x is x to the power half. Bring it to the top, x to the power negative half. An antiderivative. So what do? Increase the power by 1 and divide by the new power I get. So minus half plus 1 is positive half. Minus half plus 1 is positive half. Division by a fraction is multiplication by the reciprocal. Okay, so that is 20 x to the power half. So so that was the antiderivative, mind you, correct? So now you are finding integral from 1 to 8, 10 over radical x dx. So I'll take this antiderivative, evaluate it at 8 minus, evaluate it at 1. So 28 to the power half minus 21 to the power half. 1 to any power is 1. So it's at 20. So that's your final answer. Now how do you input that? Be careful. So the input of this is 20 times 8 power, because power is a fraction. If power is a fraction or a negative number, use parenthesis. All right. So minus 20. Okay, so this completes problem 7. Next video we start problem 8.